Hey, good morning, everybody. Happy Thursday. How you guys doing? All right, it's almost done. Should we let that one fade out? Got a couple things on tap for today. Not too much, actually, which is good. We'll have some time to talk about the project. Definitely saw you guys chatting about that. Which is fine. Questions are good. Questions are good. Alrighty. Grab our schedule. All right. There we go. Awesome. All right. We have more chat. I don't have words today. More on inheritance from chapter 10. And then we're going to talk about the next project as well. Okay? And any questions you guys have about project 2, our poker, heads up poker, I forget what we called it. I'm out of it this morning. All right. Oh man, is my internet even working? All right, I think so. Just locked up over here. So what questions do you guys have about poker? Yeah, and definitely chatting through this with other classmates. Go talking about it in study sessions or just getting together separately would be very useful. Like when you're programming, it's really hard to do it all by yourself without at least talking about design with other people, and that's a great collaborative step. You can say, oh, I was thinking it might look like this, or we might have these kind of features, these attributes. You don't have to get into specifics and say this is specifically what I'm going to code. But we can say, oh yeah, sure, I'll have a class and it'll look like this, and that sort of collaboration is fantastic. And I think we've had a pretty good chat in Discord going there on our channel for some tips and tricks. All right, one, you're all set then? Yeah, every tie break for every hand. So the different hand ranks that can tie break, right? We're gonna have code for that. So we want to test to make sure our code's gonna work. The code for whether one rank beats another rank is super easy, and I think I actually gave that one to you, right? Excuse me. Let's take a look. We did some starter code. I could open it in NetBeans too, but I'll start NetBeans opening at least. Let's see if it takes a while. Right. For one hand versus another hand, that part's really easy. One test gets us the code coverage here for is this ordinal better than the other ordinal for my hand ranks. Just to make sure we did it in the right direction, because it's easy, right, to make a mistake and say, oh, well, maybe I had them out of order or whatever it happened to be. So this is a good quick check. Just one. We don't need to test every hand rank against every other hand rank, right? Because that's not getting us more code coverage, essentially. It's not a bad idea to do, right? But, if we're just looking at that code coverage, just does one rank beat another? Great, that one's done. Does one rank lose to another where we'd expect it? Great. Then all the tie breaks. This is where all the testing is going to happen, right? Because our different poker hands will have different results. So straight flushes, they can tie, they can win versus another straight flush, or they can lose to another straight flush. So that's what we're testing there with the unit tests, right? We're saying, all right, here's where I would expect to beat another straight flush, here's what I expect to tie another straight flush, and here's what I expect to lose to another straight flush. Four of a kinds don't have ties. So you're either winning as a four of a kind or you're losing as four of a kind. So we can test each of those scenarios to make sure we've done it the right way. And believe it or not, just testing win doesn't test lose, because it's possible that we screwed something up and we just assume the first hand wins or something like that, right? So we want to catch both conditions, because it's not like we're saying, hey, my hand wins, the other hand loses, because we really need to check that. Okay, and we could even do it in the same test, right? We'll test that the better hand wins to the worse 4 of a kind, and that the worse 4 of a kind loses to the better 4 of a kind. Right? We're still testing in both directions that way. Full houses, again, you can't tie with a full house. You can tie with a flush, you can tie with a straight, you can't tie with the 3 of a kind, you can tie with the 2 pair, you can tie with the 1 pair, you can tie with a high card. All right, and I see you guys were just planning on what words to ban. No one actually redeemed a word ban, right? I don't have to worry about that right now. All right, cool. Close that one down. The deck class. Someone was talking about the deck class. Let's take a peek. Don't think we started anything with deck, right? So the idea with deck was that it would have a bunch of cards, right? And then we can get one randomly out of it. Right, so deck then had probably an array list. Doing this with an array would be really obnoxious. So an array list of type card is much easier, right? Our cards or something. And then in the deck class, then the constructor, we need to go make cards. So, and a couple of you had this issue, and that's okay. Right? The idea is that we're declaring the variable here, but we need to instantiate it. We need to create it inside the constructor. The constructor's job is to give values to all of our attributes. So we got to create that. So cards is equal to a new array list of type card. And we could size it, right? We could tell it, hey, it's going to have 52. It's not going to hurt anything if you don't, but it'll be ever so slightly faster if you do pre-size it, because we won't have to do any of the resizing stuff. Yeah, tie breaks there. So if we have our hand in sorted order, right, and we know low to high is default. If you want to do high-low, you could do that too, right? We need to look at, for a straight, their high card. Or I guess really their low card, right, because they're going to be in order, and compare them. Right? Whoever has the highest high card wins. We know with straights that the rest of them have to be in order if we know they're a straight, so we don't have to worry about the rest. We can just look at one of the cards, and if it's greater, they win. If it's the same, they tie, and if it's less, then they lose. Flushes are trickier. Flushes, we have to look at all 5 cards. Look at the highest card. Whoever has the highest card wins. If those match, look at the next highest card. If those match, look at the next highest card. If those match, and those match, whatever, we tie. If all 5 are the same. If at any point you have a higher card, you win with the flush. Same with high card. 3 of a kinds. Whoever has the higher 3 of a kind wins. 2 pairs, look at the highest pair. If those are the same, look at the next highest pair. If those are the same, look at the 5th card. If that's the same, you tie. So each one tie breaks just a little bit differently. So the 2 pair is actually a little bit tricky. I've got an approach that I use for it that I thought was cute, and I'll talk about that tonight. And then with you guys next Tuesday, I'll go over my solution for it. Right, so a deck then, right, had a bunch of cards. You have to go put the cards in, right? And we said you could loop through Enums. Remember when we did this thing of looping through Enums? Somewhere in here. Let me just search our... did it in one of these here. Excuse me. Yeah, we said for mood in mood values. Right, this would get out each mood we could loop through. So we do the same thing, loop through suit, loop through face, and make a bunch of cards. Right, so you got to add all the cards there into cards, and then you want to have a method like that will return a card, like get random card. Oh, my curly brace is in the wrong spot, sorry. So we need to get a card out of our deck, right? And I said, so if we have random, equals new random. And this actually could probably be better to declare up here. Not that it matters too much, but this will keep us from making a new one every single time we want to deal the card. Call it private and import random. There we go. Cool. So if we want to get one of those cards out, right, we can ask our cards. We can say get size. Size will tell me how many cards are in there. So random.nextInt up to size. Capital I. It's capital in there somewhere. Yep. Up to size is going to give you a number between 0 and the last index. Right? Because it's not inclusive. So size is great. Gives me everything. And I can just get a card out of the deck then. Right? Return my cards.get. from that index. Oh, here we go. That's the random index. Right, but that doesn't remove it, right? This is just going to return it. We still also need to take it out of the dex. We can't just return it directly. Right, we have to remove from that item, from that location. Right, so if we remove from that index and we return it, we should get our card. I think remove gives it back, does it? Yeah, remove will give us the type of card that we're removing. Right, and that pulls it through. So again, you still need your loops to fill it up. Right, loops. All the cards from Enums. That's it for deck. Right, put all the cards in. So every time we want to start a new hand, we'll just make a new deck. Right, in that little play loop. Then we get random ones out. That makes sense for deck? Sorry, who is asking? Yeah, Yogi. And Avanso, you good with tie breaks? Or at least coming along a little better? Put that out there. All right. Okay, cool. And again, do pay attention to how this is scored. That will save you some headache. Right? If there's just something you get stuck on, don't worry too much. We can, 1 point's not the worst thing to just not be frustrated about that one thing. You can always come back to it. The copy thing, this copy constructor. Yeah, so our copy constructor, the idea was, how do I make one instance from another, but I don't want to have shallow copies, because I don't want to have two variables pointed to the same location in memory. So what the copy constructor lets us do is take one instance of a class and make a new one out of it, and it's going to make a copy of all of its attributes. Now, in our case, it's a little bit silly for card because you can't change their values anyway. So it's just an exercise in writing that copy constructor and going through and setting the attributes, right, making sure we have copies. We all point to Enum, so it's not a big deal in card. So I think we even wrote it in card, didn't we? I didn't write it yet. Do the copy constructor thing. Maybe we have to take its attributes and assign its attributes to my attributes. I only did suit here because I didn't finish the rest of them. So we have to assign this card's suit to my suit. And this card's face to my face. Again, I don't have the face. You guys can go add it in. Someone had a really pretty one that used Unicode characters to represent some of these things. I'm not that fancy, but no, that was really cool to see. I'm missing a semicolon? Does it need a semicolon? It didn't yell about not having a semicolon. That's interesting. Right, so that copy constructor thing will take these values from this card where it was given and assign it to our own card, the new instance, or this instance attributes. So we're setting the values. Yeah, probably too fancy. It's just, we'll take the suit, assign it to our suit, take the face, assign it to our face, and that's it. So we did these copy constructors before. Let's see, did we do them in here? Copy constructor. Let's see if we can find it. Oh, I can't spell. Constructor. Maybe I left a note. Yeah. So we did stocks. Right, we had a copy constructor for stock. When you give it a different stock, it would copy these over. Now again, this one was a little bit silly. Our strings, this was a little bit bad, but strings are immutable, so we don't have to worry too much about that. It's more interesting if we have reference types. So like if we have a list of things, or if we have other classes, because we can't just copy one to the other, we have to go through and then copy those ones as well. So do we have any more of those? Portfolio. Let's see. Copy. Makes a new instance, yeah. Just looking at all the notes. Is that the only place we used it? Yeah, so we're looking at, actually, those are actually new. All right. We didn't do a whole lot with it, with reference types. Yeah, but so pay attention, right? How you get the points. So 9 out of the points, out of the 15, come from each of the hand ranks. So if you get stuck on one of the hand ranks, just skip it for now, right? Worry about getting the rest of the points in there. Yeah, it's always good to cite a source. Just drop a comment in. Say, hey, YouTube, no, or like, watched a YouTube about this. Oh my goodness, can't type. And then, drop the link here. That's fine. Yeah, so really, anytime you are getting information from outside, that we're still in the academic world, so we're always going to cite our sources. You'll get paid to do that in the real world as a software engineer and a developer. But you still really good to cite sources, even then, because then if someone is trying to understand why you took this particular approach, they can go see the source. Right? Never hurts to leave those comments in there. As much as I don't use comments, it's really good to cite sources and say, hey, I got the information from here. That's always good info. Need more coffee. I think I'm out already. Yep, I have to refill my mug later. It's a sad day when you run out of coffee. Okay. We okay? Ready to move on to chapter 10 again? Or you got more questions about the project? Pull this up, make sure we're not missing anything here. 10. Okay, let's see. Where'd chat go? Oh, it got funny. That's weird. Right, I think I still got chat. You still all right there? Yeah, good. We're there. Just like needs to refresh itself. There it goes. Okay, so remember a couple different terms we're going to use. Polygon here was the superclass, or the parent class, or the base class. Rectangle is the subclass, or the child class, or the derived class. Lots of different terms for it for whatever reasons. And we use this extends keyword here to say this is the class I'm explicitly extending. Okay? When we have private attributes, oh, isn't it used? It's not used. That's fine. Oh, we never had a get number of sides, did we? We should have a get number of sides. So we can add that. Insert a getter for number of sides. Done. See, aren't those warnings helpful? Occasionally they are. All right, so private attributes can't be accessed by our child classes. So in here, right, even in my code here, I can't do anything with number of sides. Right, I can use the get number of sides method that's available to me, but I can't get it directly. A posture check, thank you. Uh-oh, is my chat locked up? Let's see if I can like pop it out. Oh yeah. Yeah, questions on the project are fine. Where did that go? There it is. Thank you, thank you. Keep me from slouching. You're looking out for my help. I appreciate it. Yeah, what do you got about the project? I think I'm upsetting my chat. Give me a second. I gotta refresh here. Sorry. Let's see. See if that works any better. Oh, of course it clears chat. Oh, okay. I think I'm back. Yeah, that seems to work. I was just seeing. Did I miss it there, Gatton? Or are you still working on it? A random method to get a card. Yeah, if you want to shuffle it, that's fine. Like if it's shuffled, then getting a card will get a random card for you. That's fine. I know there's some ways to do shuffling and whatnot, but it's just as easy to pick a random one than it is to call shuffle. Yeah, for sure. All right, so we can't get at our parent class private attributes, right? And we don't want to make these things public. That's a bad practice to make those public. Turns out there's another level of access we can specify, which is cool. So what we can do is we can use a new level of access called protected. So there's private, what we've used, no one else can touch. There's protected, which is private but open to subclasses, which is cool. So I can make this protected, my side lengths here, and at the protected level, a little note here, so protected is access to subclasses. Now over in rectangle, now I can get my side lengths. Right? I have access to side lengths here, and it's telling me, hey, it comes from polygon, but I have access to it. I didn't have it before, and I can do whatever I wanted here with side lengths. Right? So maybe we wouldn't have to do all this superclass stuff. We could just go set it ourselves if we had access. But there's nothing wrong with calling it to our superclass using that public method. Okay. And then we talked a little bit about constructors. So the first thing you have to do is call your superclass's constructor. If we didn't have this here, it was going to yell at us, right? And it says, oh, constructor polygon in class polygon cannot be applied to given types. Acquired int, found no arguments. And you might be confused thinking, well, where did we call the constructor here? So it happens by default. So Python is, nope, this is Java, this is not Python. Java is smart enough to say, oh, you have a subclass, we need to call that constructor. So it's getting implicitly called here. What super lets us do is explicitly say, hey, I want to call it and I want to give it these parameters. But because there is no argument constructor, right? The only way you can make a polygon is with a number of sides. We don't have one that will take 0. So that's kind of a weird constructor to have a no-sided polygon. Then you have to give it a number of sides. So we call super. Now, if we wanted to take this a step further here, and I know this is a little boring, but that's okay. It's contrived. If we were to make square, okay? Square then extends rectangle. So square is a rectangle. And so if we were to class for square, now square maybe wants an int for side length. Right? When we make square, because why not? Right? Make a square, tell me how big it is. We don't have to set individual sides at a time. It's not a big deal here. Right? Now notice it's not yelling at me about that missing superclass call because rectangle has a no argument constructor. So it's going to call rectangle automatically. I don't have to even say super here. Right. Do this explicitly. Explicitly happens automatically. You know, but we could put it in here if we wanted, just to give ourselves a note that, oh hey, remember it's going to call that superclass constructor. They call those a no arg constructor, no argument constructor. It's going to happen automatically there, that call. Okay, but if we have a side length, then what we're going to do is we want to set our side length. So super dot set side length. Nope. Set side length. Yes, that one. 0 to side length. And 1 to side length. Because I know that's going to set all of them for me. Right? And then we want to override. We want to change the behavior of set side length. Because I wanted to do something different when I set side length. Maybe we should have done that. That's what we should do. So set side length given an int side index and an int side length. Do this thing instead. So in here we can just call our own set side length method. 0 and side length. So we don't actually care what side you want to say. We're going to set it for both. And then we should have that little @ override here. This is technically optional, but it's good practice, and it'll help make sure that we're getting it the right way. Remember, this is telling our compiler, hey, make sure that I'm actually overriding something, because it's really easy to typo things, and then if you typo it, we're going to be in sad shape. Yeah, we don't need any missing. Oh, no, I didn't want the Java doc. Did I click that? I clicked it. Uh-oh. What did I do? All right, I don't know if it actually changed anything. That's okay. Okay, and we can have as many of these relationships as we want. I don't know what is also a square, but we could extend square if we really cared to. Right? The idea here, this inheritance creates that is a relationship. Right? We are a type of our parent class. So squares are rectangles. Rectangles are polygons. Squares are polygons because squares are rectangles and rectangles are polygons. Right? So you get this whole hierarchy of inheritance here, which is fun. Now, if we wanted to, here, let's see, we don't really have any any interesting methods here. Maybe we could here. This like maybe get area. Right? So we could use it here. This is silly here, but the final keyword prevents overrides. So if we said final int get area here, final is going to prevent you from overriding. So if I try and override get area, public int get area, and then we're going to return, just for silly, I don't actually need the right thing in here. Now it's warning me, can't override, because the method is final. Maybe we get a nice warning here, you shouldn't do this thing. Take out our override annotation, still tells us can't override because it's final. Okay, so can't do this because it's marked as final. So I'll just comment that out. There was the what was the insert comment? Nope. Why can't I remember that screen, the shortcut? Toggle comment, control slash. There we go, control slash. So we have protected. Yep. We have private. right? And we have public. So typically we don't like to make attributes public, we make methods public. Right? This idea that we want to encapsulate all of our details, right? We want to have one abstract way of interacting with our class. That's our abstract interface, or our API, right? Is all the public methods. The ways in which you work with a polygon are through its public methods. You don't need to know its private details about how it has a particular array list, or if it has an array, or if it uses other whatever it wants to do to track. Right? We don't need to know those details. We just know that these are the public methods we can use. So we can interact with it abstractly, and it encapsulates all of its own details to protect itself. Right? A class should ensure it has integrity. It shouldn't let you give it bad values. And we haven't talked about exceptions, but we'll get there. Right? But we can create specialized versions of our parent classes with inheritance here. Right? It is a type of its parent class, but then it will do special things. Whether or not we're adding new functionality like area here. Right? This was new. We couldn't do that with other polygons. We can do it now with a rectangle, though. Let me get that a format, actually. Right? Or we're overriding previous behavior. And this is all about making sure we have integrity. Right? If someone tries to set the side length, we need to make sure we're setting both, because otherwise we're not a rectangle. Okay? Now, here's a fun thing that we can do. Okay? This is fun. And this is one of the last core pieces of object-oriented programming and object-oriented languages. So what I can do is I can make an array list. Just depends on what you're trying to build, whether or not extending things is proper or not. You know, I mean, the language supports it. It's made to work like that, and it lets you create specialized versions. If you're using a lot of them, you know, it probably depends on what you're building, but there's nothing wrong with it. There's nothing wrong with doing inheritance. But you gotta make sure it's particularly an is-a relationship. I've had some weird things, especially like when I assign poker projects and things, where people say, well, hand extends deck, or hand extends card, or something like that. And you get these weird relationships that really aren't is-a relationships, right? A hand is not a deck, right? It doesn't give you random cards out of it. You don't, you know, shuffle them all up. You don't have all 52, anything like that. Or it doesn't extend card because it's not a card. It's a bunch of cards. So we have the is-a relationships, or we have the has-a relationships. So the has-a relationships are composition, is what we call that. We say we're composed of lots of other classes, which is fine, right? But we aren't that class. We happen to have a list of cards. So I can make an array list of type polygon here. I'll call these my shapes. It was a new array list type polygon. And yes, we want array list. And here's where nonsense happens. Well, it's not nonsense. We can say shapes.add, right? We want to add something to our array list, right? Of polygons. I can add a new polygon of, you know, how many sides? This one might have 4 sides. Sure. And I can call add, and I can add a new rectangle. Oops, shapes. Add a new rectangle. And I can call shapes. Oh, I can't spell. Babies. Shapes. Add a new square of, you know, size 10. Why not? This is all fine and good. It's supposed to only hold polygons. Well, it is holding polygons, right? Because a rectangle is a polygon, and a square is a polygon. And I can call like shapes.get, you know, 0. And I can do all the things a polygon can do. Get number of sides, I can get the perimeter, I can get the side length, I can set the side length, right? I can get 2 out, right? That should be my square. Notice there's no get area. It's only of type polygon. So what we get is we get this, we'll call this polymorphism, where we can treat an object as its parent type, right? So we can change its behavior based on how we're referencing it. So when we reference all of these as polygons, Java says, oh, sure, put a bunch of polygons in. Because it only thinks they're polygons, we don't get any of the special stuff rectangle and square do, right? We don't get the get area. I think that's the only special thing we have here, right? Because Java only knows that they're polygons. But any of that behavior, any of the methods that they have shared, I can use. So let's have fun. We'll say, so shapes.0, let's set side length. Oh my goodness, that is not a helpful thing. Set side length tab, yes. Right, 0 and 4. I don't know, let's just set some side lengths here. And how about 1, 2, and 3? I don't know, let's make these some different values here, because why not? Okay, and then shapes.get 1, set side length. So this is, I really gotta stop hitting tab, set side length here. Let's set 0, I don't know, to 7, and let's set 1, 2, 4. Okay, and then we'll call shapes.get 2. We get the next one out, the square one out. Okay, and we'll call set side length. Set side length. There we go. Of 0 to probably doesn't matter here, and say 9. Okay, and then we're going to say for polygon shape in shapes, let's print our shape.get perimeter. Okay, that little format. So what's going to happen here is when we call side length, this is where we're going to get magic. This is really cool. So I'm going to put a breakpoint in here. We're going to watch it in debug mode. Let's start it in debug mode. All right, so we got to our line, we're paused. We got our previous rectangle with area and perimeter. Things were working good there. Now I have variables. So I have this shapes array list. And sorry, I can't really zoom this one in. Now, Java knows it's a polygon, a rectangle, and a square. Right? It knows they have side lengths, number of sides. And it even shows, oh, those were inherited variables. It's all well and good. Right? But its side lengths here are 0 to start. These side lengths got set, right? We set 4, 2, 7, and 5. Right? 4, 2, 7, and 5. We know we did that. Now we're about to set our rectangle side lengths. I'm going to shrink that one down. So we're just kind of exploring these, looking at these. Okay? I want to step into here. I want to watch what happens. Step into. There we go. We're in set side length, but we're in it in the rectangle version. Even though we're treating all these things as polygons, right? What we get is while the program is running, Java is going to see which class it actually is and use the correct method. Use the overloaded method version. So it's dynamically finding, hey, which method should I actually use here? I know they're all polygons, but if you're a subclass of polygon, if you're overriding it, we get that behavior, which is super cool. And then we'll see, yep, we're going to set 1, 2 in there. Boom. And we set the next ones. Right, so now all those side lengths here were set because the get side length of rectangle was used. And it's going to do the same thing here with square. If we step in, now we're in the square side length, which we're just going to call the rectangle side length, and on and on and on. But we get dynamic matching here. Let's continue that out for the perimeters. So it should be right. Right, 4 plus 2 plus 7 plus 5, so 12, 16, 18 perimeter. Good. 14 plus 8, 22. Looks good. And 9 times 4, 36. So we got our perimeters out. So what polymorphism lets us do is get the correct overrided behavior even though we're treating it as the parent class type. So the book has its whole example of like graded activities, and which is all fun and well and good. Different ways of getting out scores and things. And that's all fine. So that's the dynamic matching or dynamic binding to the correct version, which is awesome. Okay, all right so far? So that's the basics of polymorphism. And I'm hoping, let's see, that we had talked about that before, right? Because some of the things we should have done in 1500, I've talked about methods, abstraction, encapsulation, and inheritance. I don't know how far you actually got into that talk there in 1500. I don't know if we got into polymorphism or not. But hopefully this was a good refresher from some of those things you might have like touched real high level on in 1500 and that didn't get very deep into. We went a little deeper, and then our project will take us even further so where we can practice this. This feeling okay so far? Oh, I go get my coffee. Actually, I think I'm gonna make more espresso. My little mocha pot. That goes pretty quick. I don't know if I can brew a whole pot of coffee in 10 minutes. All right, awesome. Awesome. We're doing really well getting through some of this content. We've got more to go here. A stretch. Oh, thank you. And you're gonna make me sleepy though, but if I stretch too much, Snake. Oh. Thank you. And I think you had sent me something on Discord. I haven't had a chance to look at that yet, Snake. We're getting ready for class, but we can chat later. Yeah, you're doing well. You guys are doing good. Excuse me. Yeah, we're going to talk about Project 3 today. Yep. For anyone who wants to get started early. Yep. All right, cool. So I think that's as far as we're going to take it for Chapter 10 today. Why don't we take a quick break, and then we'll come back in a little bit. We can talk about the next project and any other questions you have about Project 2, which is due tonight. And then we'll give you back a little bit of time to work on it. Don't forget there is study group today at 4. It's probably a little bit late to bring your Project 2 questions to study group at 4 p.m. when it's due at 6 p.m. But, you know, we have it regularly Tuesdays and Thursdays at 4, Wednesdays at 6. Would definitely encourage you guys to go and chat. And again, chatting, you're more than welcome to talk about some design ideas, and this is how I might approach problems for projects. But if you're starting to take notes, right, and like write down specifically, okay, this step, we've gone too far. Okay? So just chat about it. Get a general idea, get a sense for an approach. That's all well and good. And, you know, talk about some more of the material again. This stuff takes practice, right? It doesn't click automatically every time. And if you feel like it does, that's awesome. And then when you start writing and all of a sudden you're like, oh wait, it doesn't click, that's okay. It takes lots of practice. That's why we have homework, right? That's why you do homework in math class, to help practice it. That's why we have homework in programming classes, to help you practice it, right? And take some of those concepts and apply them. All right? So why don't we take 10, and then we'll come back. I'll have my coffee, be feeling better, get a good stretch in. We'll talk about the next project, and then if you have any other questions about Project 2, let me know. We're coming along. I think talked with a bunch of you. As you have questions, you find me in Discord or email, and I think it's going well. And I saw a couple submissions already. Haven't had a chance to look at them yet, so I take that as a good sign. So maybe that's wrong, but I'm assuming it's going well because no one was screaming, and a couple of people asked good questions, and we figured out what was going wrong. Okay. All right. So let me put on some more music. And then I'm going to make some coffee, some espresso, and then go from there. All right, put this back on to break time. Let's do 11:02. Wisp the Third, you gotta talk to me. You gotta tell me what's going on so I can help. Alright, folks, we're back. Alright. There we go. So, just fade that out nice and gentle. There we go. That's so much better than just turning it like off so fast. There we go. Alright, hydration. Yeah, I got my espresso. I am pumped. Let's see. Well, it's a little hot right now. Just finished boiling. So maybe I don't want to swig on that. Alright. Another posture check. Yep. I got the backboard. Thank you. So make sure you sit back on that. You guys just get too many channel points for sitting around in class, don't you? I had an idea to add some more. I thought would be fun. A hat, yes, thank you. Let's see. Let's go with the chest bra hat today. All right. They're a lot of fun if you're into chess, for sure. And a dad joke, you got it. You're just stalling now, aren't you? Okay. Let's see, I picked up a couple here. Found a couple that you guys might appreciate. What room do ghosts avoid? They avoid the living room. All right. Yeah, if you're sorting in a deck, so the deck doesn't need to be sorted or not sorted or anything. You just add all the codes or all the cards to it. Just pull a random one out is what should do nicely for that one. Yeah, they're not going to sort unless you actually finish it. So I didn't write everything here for you, right? Like you should compare those face values, look at those ordinals for our faces. I didn't do that part. I left that up to, for an exercise for you. So if they're comparing properly, then they should sort no problem, low to high. And if it's not working, I can take a look later. Just send me a message. Although today's a little bit tight, I'll see what I can do. Okay. All right. Yeah. Sorry, you guys. Sounds like a couple people are having some trouble getting everything through. It's tough. The work is definitely going to pile up, which is unfortunate, right? But the next project will be worth more points, and the project after that will be worth even more. So that might help make up for some missed points, and it's all point based, right? So take a look at the rubric. Do the things that you can do for points, and don't do the things you can't do for points. You definitely can get some partial credit there for things. So do focus on that. I think is a good rule there. We can pull up that rubric. I think you guys see the rubric differently, right? Does it show up down below the assignment or something? I forget where it shows up. Right. So, some of the playing the games, 2 points here. So just having the deck, which is mostly written for you already. Mostly. The card copy constructor, card with enums and faces. So you can get a handful of points here without the working poker hand. Or if you start poker hand and you can only do 1 or 2 of the ranks, that's okay. You can still get 1 or 2 points for the ranks there. So you can just take it piece by piece by piece. It's definitely the best approach there. Okay. All right. Other questions about the project? Or are you ready to talk about project 3 coming up? Now I need to look at the schedule because we have a midwinter break coming up, right? That's not where I want to go. I want to go over here. I need to make sure we're not going to drop this in the middle here. March? Okay, it's in March. So that puts it 2 weeks out from today. Yep. And then we have the midterm after break. Hey, glad the tips were helpful. Hips were helpful. I have not had enough coffee. Actually, that's a lie. I talk like that anyway. Sometimes coffee just makes it worse because I'm more hyper. Yeah, so that's unfortunate. Okay, that's right. We're going to put it off for a little bit longer. We've got time to do that, right? I'm talking to myself, folks. Sorry. I'm talking to myself. So I don't want to have it do the same work week as the midterm. here. So I think we're going to push it out all the way until the 18th here. Seems like a really long time. That's okay. And I don't want to do the same day as you guys have to worry about doing a midterm. So yeah, it won't be till the 18th. Oh my. So if I assign it now, and it's not due till the 18th, what are the odds that you find folks don't start it until, this week here? Just wondering what the odds are there. Honestly, I do the same thing. If the deadline is a month out, I'm probably not starting on it early. Even though we all know we should, right? Okay, let's do that then. So it'll be due the 18th. That's good. Gives us some good time here. All right. Okay, and that's good because we're going to have a couple things in here that we haven't gotten to yet in Chapter 10, because we're going to get to those next week. So those parts you can just hold on to. It won't be a big deal. So this is Project 3. Okay, and this is our I'm trying to give a good name that won't give us copyright trouble. What can we call it? It's a text-based kart racing. Sure. Trying to avoid the word Mario Kart. But just we're text-based, so it's not even close anyway. So like, it's okay. We're not going to be anything similar. All right, I got to add a new grade here. Create to a new grade item in projects. All right, and this one's worth 20 points total. You're going to submit not a file, a text. There we go. You can do that, right? Okay, and I gotta save it and go back into it. I didn't name the other ones? Oh, I thought I gave them all names. That's sad. I thought I had funny names for all of them. Okay. So, using all the stuff from Chapter 10. All the stuff from Chapter 10. Boom. Right, so we're going to have classes. We're going to have derived classes or subclasses and superclasses. And then we're going to get into this thing about abstract classes and interfaces as well. Okay, we're going to have to override methods. Right, we're going to do all those things here with our little kart racing game. Okay? So we're going to create a base go-kart class or kart class here. And this one is actually going to be an abstract base kart class. We'll talk about more what that means next week. Don't worry. Don't sweat it. It just means stuff doesn't get fully defined. Okay? Create subclasses. And we're going to have two different types here. I don't think we need to go too crazy. Maybe we could do 3 types. Excuse me. We're going to have light carts. We're going to have heavy carts. And we're going to have motorcycles. Motorcycles. Because they added that to the latest, and those were fun. Right? Motorcycles are fun. Motorcycles? Is that even... That doesn't even look like it's spelled right. Motorcycle. Why does that not look right? Okay. Yeah. Checks out. It Googles. Okay. So carts have attributes for And we're going to have like a max speed. We're going to have an acceleration. Acceleration. Nope. Just one L, really. Okay, acceleration. We're going to have this idea of durability. Like, if we take too much damage, that sort of thing, our cart will break here. And current speed. Okay, so we'll have some attributes. We'll have methods, parts. We'll have methods for accelerate, decelerate, I don't know, or go and brake or something. Slow down, brake. Accelerate, brake. You know, all the gets, all get methods. Okay, so the idea is we're going to be able to drive these carts around a track. Yeah, practicing. Mr. Gaddis has lots of good examples in the textbook. There just happen to be answers online for all of them, so they never make good assignments, or graded assignments, I should say. When I make this sort of nonsense up, it's a little bit harder to Google. I mean, yeah, you could Google the poker hand, but like I'm looking for specific implementation versions in poker hand, and that makes it harder to like find anything that's usable on Google or Stack Overflow, that sort of thing. Yeah, he's got lots of good examples there, Mindful, to practice. And get methods for all attributes. Is it lagging again? It is. Is it like this time of day always now? Seems like. That's weird. Right? Okay, so then we will have a track. Yeah, many people using the internet. Yeah, I think the kids are busy. Maybe they're watching a show or something, but it's like my upload speed. That's the problem here, and no one uploads anything, or none of my kids upload anything. They're all streaming stuff. Yeah, next Tuesday we're going to go over Project 2. I'll go over my solution. Or tonight, if you want to hang out with the evening class. I'm going to solve it for the evening class first. For sure. Definitely. Yeah, happy to go over it. I've got some fun, I don't know if you want to call them tricks, things that I do for calculating those hand ranks that I think make life a little easier. But that's my approach. I think there's lots of ways to do it, for sure. Okay, so we're going to have a track. Create a track class. It should... so this one, we're going to put the cars on the track, right? It should have a list of cars, or carts on the track, along with their position. Now, we don't want to get too crazy here, right? And an actual like track that you're supposed to be able to drive on, you have to go around. We don't want to have to track any of that nonsense. So what we're going to do is we're going to cheat, and we're going to say, okay, I know tracks have a given shape, but let's just imagine we like take this round oval and we just flatten it out, and we'll just pretend it's a flat shape here, okay? Or position. So we'll just track distance from start. Okay, so a track will have a total distance. No, how far to the end? The end, along with, excuse me a second. Whew, there we go. I think I hit the mute in time. One time I sneezed right into the mic, and everyone said it was so loud and terrible because I have real big loud sneezes. I don't know. Something's wrong with me, I'm sure. My sinuses, but whew. Okay, so our track will have the total distance, right? We'll have the collections of cart, tracking where they are, and then we're going to have turns, along with a series of turns. Or bends, maybe we should say. Bends. Each bend should have a max speed assigned, or I don't know, track the max speed. And if a cart goes into the turn at or above the max speed, or we'll just say above the max speed. Above the max speed, it will go off-road, slow down, and reduce its durability. So we're pretending that we've got these turns in the track here, and if the cart doesn't slow down enough in time, right, then it's going to get damaged because it's going to go off the road. Well, we're just imagining it being like a straight, so we don't have to track a circle. So for tracking their position, like I don't want to know where they are on a circle. I just want to know like how far they've gotten from the start to the finish here. Now they do auto steer, but if you're going too fast, auto steer in Mario Kart will still take you off-road. It'll adjust, but it's still taking you off-road, and you've lost a little bit of speed, right, as it gets you back onto the track here. And then we're also going to track this durability thing for fun. Okay? So the idea, like, we'll have a bend in the road, and if they go into it above the speed, they go off-road. So we'll just say, okay, here's where the bend is. Here's the max speed. So at 10 distance in, there's a bend. At 15 distance in, there's a bend. At 90 distance in, there's a bend. Whatever happens to be. And as our cars go into those bends, if they're above the max speed, they're going to go off-road, slow down, reduce its durability. We should just say they stop, right? Stop, reduces durability, and then we'll have to pick it back up again from there. Right, so that idea, so that's the penalty for going off-road. Okay? So track needs, so we need to be able to figure out how far the next bend is, right? So it needs a method to return the distance until the next bend for a given car, or a given cart. So like we can say, hey, for cart number 2, how far until the next bend? And then we can tell it, oh, it's 10 units away, or it's 5 units away, or it's 1 unit away. And then we're going to be controlling our carts and telling them speed up, slow down, those sort of things. Whether or not we're approaching our max speed, we can increase our current speed, we can slow down, we can accelerate, whatever happens to be. Set up the bends. So that's all going to be in track, right? And we'll assign it bends at given positions. We got lots of options for doing this. Okay. So then different types of carts will have different attributes, so that we're going to change some of their behavior for doing things. Okay. Maybe this is just a reduced speed. Well, this is reduced speed. Well, no, they can stop. They can stop. Totally stop. You go off-road, you stop. Yeah, well, we're going to have to set all of these things up, and then we'll let it run, and we can actually then control the carts after the fact. So we don't worry too much about the game portion of like how we play. We're setting up the classes here, and we're just doing this back-end work here. Maybe someone else is going to figure out how to actually give us a UI on a mobile application. We just need to write a bunch of classes here, right, that sort of thing. Or maybe they want to build it as a web application, right? So maybe we can get some traffic to our website and run some ads or something silly. Okay. So this one, we're not actually going to have to be playable, but we need to have the classes there so people can interact with it, is kind of the goal here. So we're only building the classes for the game, aren't writing the user interface. Okay. So, we could definitely do that in a loop and that sort of thing, but that's not the goal for this exercise. What we're trying to do here is, how do we set up all these classes so that they have good public methods, so that someone else then can do whatever they want to do with them, and we just have built all the logic. We put all the back-end work into it. So we've got these classes, and maybe they want to put it into mobile, maybe they want to put it into web, maybe they'll make a desktop application, maybe they'll make a web, I don't know. We've got options here once we have these classes. Okay. So then the max speed is going to be like some number of units per turn. Okay, so then the bend, right? So we need to see when they go into the turn or cross it, right? Into the turn or cross the distance to which it starts. So like if we're moving along 5 units per turn and there's a bend 3 units ahead, right? If I go 5 units, I've crossed the bend, and then I need to have that penalty if I was going too fast. That sort of thing. So there's this idea that as we're getting faster and faster and faster, approaching our max speed, right, we're going to be covering more distance on the track each time. And if there's a bend coming up, we're going to want to try and slow down earlier so that we're not going to overshoot the bend, right, and go into it going too fast. Okay, distance to the next bend for a given cart, and the max speed of the upcoming bend. Okay, this idea, so the bend there, the turn, whatever we want to call them, I should probably go use the right language here every time, is going to be where it is, right? We will assign a bend at a distance in a track, but the bend itself then has the max speed. So we can tell how far away it is and what the max speed is. So we can ask, hey, how far away is the next one? And hey, what's the max speed of the next one? Right? We need some information about the bend. Yeah, or bend could be a class, right? Could have information about it, right? If that's the sort of thing we want to track, we can have that. Okay. Then we're also going to have power-ups that can be collected on the track at given distances. No, because a bend is just a one location. It's not a track, right? It's part of the track. So the track has a bunch of bends in it. You know, depending if you want it to be one straight line, maybe there are no bends at all. Maybe it's just like a quarter-mile race, a drag race. Maybe it's a circle track and you only have 4 bends, right? That sort of thing. We've got options here. So just any way we want to position these things, we can do that. We can make it entirely twisty and turny the whole way. We could just have 1 or 2. Right? It's not really up to us to say how they're going to be used. We're just putting together the code here so that whoever our amazing level designers are can say, oh, sure, I want to put a bend in here, I want to put a bend in here, I want to put a bend in here, do that sort of thing. Right? We want it to be flexible. Okay, so we're going to have power-ups that be collected. Right? We're going to have, let's see, so we need the, maybe power-ups isn't the right term here, because they're also like weapons. And on items, there we go, items. Give distances, a cart. We only have a single item at a time. Right? And then, so we're going to have items, like we're going to have a speed boost item. Increase speed to above max for 1 turn. Right, so just increase its speed, it'll put it faster than it should go for 1 turn, and before it goes back down to normal. We'll have a shell item. Can be shot at any cart ahead of the current cart, or the cart. Causes the target to stop. Yeah, text-based Mario Kart, but it's kart racing. Kart racing. We can't call it Mario Kart. Right? If someone wanted to implement it as Mario Kart themselves, that's up to them. But our project here, we're just writing the classes. I don't want anyone to make any terrible knockoffs and get into trouble here. Okay. Speed boost item. Let's just call it a mushroom. Right? Why not? We'll go with it. Because mushrooms, of course, speed you up. That's what mushrooms do. Right? I don't know. I don't know. Excuse me. I don't know where they come up with some of these things, or but the banana peel makes sense, like to slow it down, and then a banana peel can be dropped at your current location on the track, and the next car to pass that location will spin out and stop. Okay, so you can shoot ahead, you can drop something, or you can speed up. We're going to have a couple of these items here. Okay, that will do that sort of thing. Guys with me so far? Okay, cool. So if you already have an item, you don't get to pick up new items. Right, so you can only have an item at a time. Yeah, so you can pick up the item and then you can use it, and then you'll be able to pick up the next one possibly. So don't worry about this idea of don't about trying to remove them, respawn them on the track. Give everyone an item once they cross X distance. Like so, like as soon as everyone is gone, like whenever you pass this part, you can get the item. Oh yeah, you can randomly get one of these here. So when picking up an item, randomly assign one of the following. Right, mushrooms, shells, banana peels. Okay, so some items. Well, the card game had a lot of logic around the tie breaks and stuff, but this is we're just trying to make these classes interact a little bit here. And so track just tracks the bend and has the item. So item is going to be its own thing here, right? So we're going to do a lot of that composition. So track has a lot of things. It has all the cards on it. It has all the bends. It has all the items, right? All the information about it here. So it needs to know where those things are because the cars will travel along the track, and it needs to figure out as you cross certain points, different things happen to your carts. Okay. Wisp the third. Oh, my friend. My friend. Yeah, we've got free tutors through the Academic Support Center. Check it out, schedule appointments, come to our study group sessions. We got lots of study group sessions between now and when this is due. Lots of that. You're gonna get your own. Yeah, all right, all right. Yep. All right. So the idea is that we're going to have turns that happen here. So like every turn, we're going to do a lot of things, and we can figure out where the car has gone if it's crossed certain locations on the track. Right, the cars will travel its current speed per turn. So for each turn, each cart will be able to take an action, and travel its current speed along the track, picking up items or entering bends as appropriate. Right, so actions, like the different things it can do. It can use its items, it can accelerate, it can decelerate, those sort of things. Oh, the durability, that's right. That needs to reduce our durability. You know what, let's forget about durability for now. That's okay. That's probably more than we need to do right now. Open, stop. Off-road and stop. Right, so if you stop, right, your current speed goes to 0. That sort of thing. Okay? So the idea is we're not actually taking all of these turns here, right? We're writing the classes so that someone else can manage the turns, right? Because that has to be managed on a mobile app or the website or whatever we happen to do here, right? So we're not managing these turns here. So we're not writing the game that manages turns, right? But we're setting it up so that they can interact in such a way. Right, so cars need ways to have actions. Carts need like ways to do these things, right? That's what those methods are for. A method for use item. No, so like we just imagine like in turn 1, cars go a certain distance. They're probably all accelerating. Another turn, right? They'll keep going. They'll keep speeding up. When a bend comes up, right? Some of the cars are ahead, some are behind, whatever happens to be. A car might slow down as it approaches the bend. Right? A car might pick up an item. It might shoot the item. Might use the item. Right? Whatever it happens to be. Then reduce speed to max speed. So like the mushroom will let them increase their speed above their max, but then it goes back down to max after their turn. Right? So they use the item, it should take them further along. This sort of thing. Current speed, max speed. So the acceleration is like the how much they can increase their speed per turn. Excuse me. So acceleration is they can increase their current speed per turn. It's not an exact. We're not really doing real physics or anything. And I know that changes based on current speeds and conditions. But we're just going to say, sure, this is their max acceleration. So if they want to accelerate, we'll increase their current speed by this amount. Sure. If they want to brake, we'll reduce their speed to whatever here. So brake reduces speed by up to, we'll say, we'll just up to an amount. So we probably should have then a brake speed. Does that make sense? Brake speed by up to brake speed. So heavier cars, when we get to actually riding heavy carts, their brake speed will not be as fast because they're so heavy, right? They won't be able to decelerate as fast as light carts will. That sort of thing. So then the max, you'd have to make more items in the constructor. So like you would use the mushroom item. So a cart can use an item and it should affect its attributes by using an item. Yep. accelerate, so accelerate that is, oh yeah, right here. Accelerate. So that will increase their current speed. Increase their speed by up to acceleration. Brake reduces the speed by up to the brake speed. Get methods, method for use an item. You know, get item, that sort of thing. Attribute, brake speed, item. Because cars can have items, right? So you'll have an attribute for item. Okay. All right, so then what is going to make these classes different about the rest? So the cart itself, right, it's going to be the base class. It's going to have all these attributes. It's going to define some methods. We're not going to implement all the methods. We'll talk about abstract classes next week. Don't worry too much about it. And then these specific subclasses then will do certain special things and have different behaviors, right? And the reason why we need subclasses is we can't just have a bunch of different behaviors in the base methods. We need to implement different behavior, right, as we do these sort of things. So it's not just their attributes aren't going to be different, like they're going to behave differently as we do things. Does that make sense? So, all right. So then, let's see. It's carts. Make some room here. So then, light carts, right? So in general, like their attributes will have better acceleration and brake speed. Right? We'll have higher acceleration and brake speeds. Right? That's just in general about their attributes. Those sort of things. The max speed is slightly less. Right, their engine's not quite as big, so they can't get quite as fast. But because they're lighter, they're going to go a little faster. Okay, so light carts then are going to have a little bit of better handling. Right, so when a light cart hits a turn, cart enters a bend, it gets a chance to decelerate or to brake before taking the penalty. Hey, I'm in class, sweetie. No, go up. I'm in class. All right, so we're going to give them a little bonus here. So when a cart enters the bend, before it takes that penalty, right, it gets a chance to slow down. So like as we're interacting with our carts here, when a cart hits that bend location, right, we're going to say, okay, you know, the cart enters the bend, it's going to get a chance to see whether or not it can brake one more time. Because it's a little bit more nimble here. Okay? Heavy carts, lower acceleration and brake speed, slightly higher max. And these are just the ways that the attributes should typically work here. Now, no one's going to force that on us here, right? We need to do some sort of balancing in the game, but just in general about them here. So what heavy carts are going to be better at then are they get a bonus. So they're a little bit bigger, right? So they are going to actually be able to store 2 items and store 2 items at a time because they're a little bit bigger. That's their bonus ability here. So we need a way for them to track when they have an item or when they have 2 items and using the items there. Right, so like add item should allow it to accept a second item and use item uses the first item. Right, so that's some different behavior that's happening inside that class, right? So it has like this item attribute. Well, heavy cart's going to be special. It's going to have room for a second one. It'll have a second item. Right, we're just going to interact with the first one. If we use the first one, the second one should like bump itself up to be the first one. So we have room for that second item. Okay. And then motorcycles. They have generally probably the best acceleration and speed and max speed. The best acceleration and brake speed and max speed. That's too many ands there, right? Acceleration, brake speed, and max speed. They're usually like the fastest because they're light and nimble here. But if they are by a shell or slip banana peel, I don't know, if they're stalled out, right? So slip on a banana peel or go off-road, they lose an extra turn from the wipeout. Okay, so this idea that if our motorcycle, they're going to be the fastest and the nimblest, but if they do crash, they're losing an extra turn. Okay, so we need to be treating these differently when they're on the track, that sort of thing. Okay, so we need to have different behavior in each subclass then from the general base kart class. Right? They all have attributes. These are just in general, this is nothing we're actually enforcing here in the game, so we don't force these in our logic. The game part will do that sort of thing, right? They're just saying, hey, this is typically what happens. What we do is we have these extra special behaviors based on our subclass here. Okay? Yeah, so the bike's going to stay. So as these, like this turn happens, right, they just don't get an action. They're stalled out. Okay, so our track will have lots of other classes. There's no inheritance there, right? There's the track, right? And then there's cart. So the cart is the base class that has all the shared behavior here, and then we implement these special versions here. So what makes light cart special, heavy cart special, motorcycle special is, well, when they enter the bend, right, they get an extra chance to brake. These ones, well, they get 2 items, so we have to have some special behavior around items, and these ones, special behavior around the wipeouts, right? We need a way to track and indicate whether or not we're recovering from a wipeout. Okay, so we're not actually writing the game, right? It's not going to be as bad as you think, because there's no actual game that we're writing here. We're just writing the classes and giving them the opportunity to interact. Okay, and we're about out of time, so I'll work on the rubric. Maybe we'll talk more about that next week when we talk about abstract classes and interfaces here, and we can go from there. There's lots of different pieces and interactions here. We're doing a lot more with classes than we were with poker. Poker had a lot of logic around the tie breaks and stuff, but it just had like deck, card, and poker hand. This one's going to have a lot more. A lot more classes talking to other classes, or having those classes having attributes of other classes, that sort of thing. So I'll do all these projects for you guys in class. So, the longest one's going to take me 2 hours, tops, that sort of thing. But again, I've been doing this for how many years now? Since 2005? 16 years? Is that right? 16? Yeah, that sounds about right. So like, I've had a lot of practice. So don't worry. Right? The reason why you guys have assignments is so you can practice this stuff. Okay? Oh, lots of projects. I worked on lots of things. Yeah, doing stuff by yourself is boring, and it's no fun. Just doing school projects, that sort of thing. So the group project is much more interesting. And the final project is going to be optional to work in groups. Usually I would require groups, but because, pandemic and this remote learning nonsense, I felt like it'd be cruel to force you into groups here. Let's see. So, hey, I'm in class. I'll be done in a couple minutes. Okay. That final project. So if you do want to pair up with someone, that's great. You're welcome to do that. We'll be building a little graphical program here with Java FX. we can go from there. Not just lots of, I mean, you're talking about like school projects that I did through school or like things professionally in work. Like there's all sorts of fun applications and things I've worked on, but um, yeah. Oh, lots of applications, backend stuff, web stuff, a lot of different things. Yep. Yeah, it's hard to just give examples. Sorry, all sorts of different stuff. All right, I think we're about out of time here. We're going to pick it up next week. Again, we'll talk more about abstract classes and interfaces in Chapter 10. We can talk a bit more about Project 3. I'll get the rubric built out for you guys. And then we'll talk about the solution to Project 2 as well. And then we got winter break coming up, midterm review, midterm exam. And we are about halfway through then as of next week. We'll hit our halfway mark. So it's been flying by. I do owe you guys some quizzes. I'm a little behind on grading those quizzes. I'm sorry. But I've got all of your Project 1s graded and up to date. So hopefully you saw that in D2L. If you have any questions, let me know. I'll be happy to chat about it with you. If not, we can go from there. Let's see if there's anyone else around we could go pester on Twitch, right? See who's around. See if I can get one of these raid things to work. Let's see. Just want to watch someone do Vim things. I think we can probably raid him. Let's try that. Vim is a text editor that some people love. Let's give this a shot. This guy's fun. It's a Knowledge Fellowship friend. All right, I'll see you guys around. I've got limited office hours today, 5:30 to 6 before the evening class, but I'll do my best to respond if you guys message me. So take care.
I'm having problems. I have some memories I need to look at. Oh,